So my topic for this particular assignment for human factors in AI is called identifying fake content on social media. So the problem that users often face is that they will interact with media content in the form of reels and images, but it's difficult to know whether that particular image is like real or not. And based on that, what happens is that there's a lot of like spread of misinformation and fake news and like lot of engagement decisions that users have to make. So the problem here is how do users know about the media content's realness or fakeness so that they can appropriately interact with the particular content on social media. So in order to understand the problem, we carry out a task analysis. So in the task analysis, the user first encounters a trigger in the form of social media content that would be an image. Then the user takes an action to check the verifiability of this particular content on Google and other sources. Then the user has to make a decision as to how does he interact with it and does he interact with the particular uh, media content. After making the decision, the user then decides to make action, that is to engage, disengage, or like share the particular information, with the final objective being that he or she needs to identify whether the content is fake or not and appropriately engage with it. Now, the interjection would be to use a tool that would be a web extension to help the user identify whether the content is like a verified from a verified source, whether it is fake or whether it is real. So insights after the usage of the web extension, user will be more informed and they will find it a lot more easier to control their engagement on social media after seeing the results from our model. So for the user experience, we'll first discuss about the user interaction and then we will talk about the user experience design with respect to the model at hand. For user interaction, the user first interacts with a particular Chrome extension. He clicks on it. After clicking on it, you'll be able to click on any particular image. And after clicking on any image, you will see like a small card which will have the confidence scores of the outcome. And here you can see like it clearly states whether it's like fake or not. So you have 3 degrees of how fake or real it is. Less than 50 is shown by green. Between 50 to 65, that is like it's slightly high probability of it being slightly high likelihood of it being fake, and greater than 65 would be represented by red as a very high probability likelihood of it being fake. Users will also be able to see what other people have voted for the same content in the form of a graph. So if it is false, you can see that more people have voted that the uh, particular model prediction is like false or true. The user will also be able to provide like explicit feedback in the form of the thumbs up and thumbs down. Implicitly, if the user does not interact with the thumbs up, or if he presses thumbs up, it will be recorded as one. That is a correct prediction. Otherwise, when the user presses on, thumbs down, a dialog box, a feedback box will be presented where he can provide more information about what he thinks about the particular model prediction when he does not agree with it. Now let's talk about UX design. Here the user inputs are clearly the image that the user will click on. The feedback loop will be in the form of explicit feedback that we just discussed using the thumbs up and the thumbs down. Implicit feedback would be the correct predictions which are being recorded when the user does not press on thumbs down. Uncertainty communication, this is done clearly as shown in the form of the insights that users see based on what other people vote for the particular model prediction, as well as the like confidence estimates. The model transparency, proper citation as well as showing the model cards, the data sources is very important. Besides that, Shapley values of the image will provide a lot more insight into why a particular model made a given prediction. Now, for privacy considerations, the given data is stored in the cloud as well as the model which is stored in the API is also hosted in the cloud. Now, the image data that we use as well as the users click on for checking whether it's real or false will be recorded, and hence that may be a source of PII, hence the FIPS applied to us. Image data as well as the feedback from the users could be from like different regions, could be from European regions. GDPR will obviously apply. Uh, the feedback will be anonymized and it's pretty easy to anonymize since it's usually like in the form of text or links. No other modalities, so that won't have any PII laws. But since the more data storage restrictions would apply due to GDPR, uh, distributed training using federated learning or differential privacy approaches are possible. For the ethical considerations, there are a lot of sources of bias in the given scheme or the given system. The data itself could have representational biases as to like what is fake or what is not. So that needs to be taken care during the data preparation phase. Then learning biases can occur mm, based on the model that we are choosing. For example, if we are using embedding based models, they all embedding based models for like computer vision based models, like for example transformers or for example CNNs, all of these models have certain bias, so this needs to be taken care of. Besides the learning bias, a feedback loop bias is possible because, as you can see, the vote, the vote that the users do, this is the based of feedback. So this feedback, which is also recorded and shown to other users, can be a source of bias as well as a source of manipulation uh, when certain group of users decide to do like a spam attack on the given system. So this needs to be internally audited for the fairness measure. So besides the fairness measure, uh, we also need to be accountable for our system and our models predictions. This can be done by being open about and openly communicating the model's performance as well as the current uh, current current failings on like social media platforms as well as proper documentation, and users should also be given proper communication channels to contact the organization in case the current feedback loop mechanism fails and the model is probably behaving in a very weird manner that the user likes to give a feedback on. For transparency, besides the SHAP values that would provide transparency into the model, description of what data sources are being used, as well as the collection practices that are used to make the system will provide insight into transparency. So that's it.